So, hi everyone, we are from Broadcom. Myself Kalimuthu, Senthil is my co-worker. Unfortunately, he could not travel today. So, I will be taking through the entire slide deck. So, today's agenda is we will deep dive into the AI space. So, how actually AI works internally. So, we will see how that the internal black box we can understand how we can utilize that benefit into the SONiC. So, majority of our presentation will be deep dive into the neural network part, that is the core part of AI. Before we get into the details, let me give you a little background on the computational part. How many of you from AI background are at least familiar with AI? I know we are all from network domain. So that I can talk more depth if it is not many of known to the AI space. I think okay, thank you. So, I'll try to cover as much as details how AI internally how it works and how we can bring that intelligence into SONiC. If you look at the evolution of computer execution, the early days, now the computer can perform anything, right. So, it can do multimedia, it can do text processing, a lot of things it can do. Even SONiC is one of the computer type where you can run all our protocols, right. So, but the evolution, if you look at the way it is started, it's from the low level electronic circuit, where it can operate the signal either 0 or 1, which basically mean on or off. So, the two fundamental primitive operations of the computer or the microprocessor either is add or subtract. That is only two fundamental operations in the computer. Later they developed few more operations like multiplication, divisions and comparisons. So, still multiplication is multiple additions of operations, even the division is multiple subtraction, even the comparison again the subtraction, if it is negative it is greater, if it is positive it is the other way around, right. So, they formed a next level of layers, and after that they evolved into the next space where they developed a assembly language, where it is little more compatible between the machine as well as the user. Then it evolved into the high level language, where it will give a better understanding of how to operate the computer, how to quickly we can put our problem into the computer understandable statement. And after that it evolved more and more languages after that. Now on top, everything on top we have now AI. So, AI is also like it's a computational background. It's simply if you say it's a statistical math. So, it will operate the number from 0.000 to 1.000. So, any number between this range is the number for the AI. It's a basically we will tell it as a neuron range. So, this is the primitive for the AI. So, I think most of you familiar with ChatGPT, right. So, I inspired the ChatGPT through which I started my research into the AI space. So till before ChatGPT, I thought like ChatGPT is, the AI is like a chatbot. You ask query, it will give some reply. It's a natural language processing, it will give some reply. But GPT changed the whole world. So the main reason is the reasoning behind the GPT models. It can think, it can respond. Basically, it can understand what you are talking. That's the real background black box behind the GPT. So I'll cover how it works internally. We'll see how it works. So so one of the use case we took in SONiC to utilize the benefit of AI. In SONiC, we generate lot of logs. So it includes your error event logs, error messages, and your debug infos, and many more things. So if you take the log of if you deploy a SONiC box in a customer environment, it will run for years. So if you take the log, or if you want to see the health of the system, you need to run through the so many logs to see how was the stability of the system. Unless some SNMP event or trap is generated, you won't know how the device performance, device stealth, all those information is unknown. So that's where I see as opportunity for bringing the AI into the SONiC. So what we did a POC on the log analysis part. What we did was, so we trained the AI with a lot of logs, and we query the network model like the healthier of the system. Like for example, if you feed the 30 days log, you can ask the AI model how many times the Docker is restarted, or how long the particular process is running, or how many times the port is flapped. So everything is in the log, but what this analyzer will do, it takes each log and it trains into the model, so that whenever you ask a query, you just retrieve and give it to you as output. I'll see how this internally works in upcoming slides. This is the one POC we implemented, and there are still a lot of opportunities. We can bring in a lot of AI intelligence into SONiC. So the main use case I see with the POC what we did, one, it can do predictive analysis. Like mostly what we do, once we get the error, and then we go and check for all the logs, what happened to the system, why it is port is flapped, and why packet is not retrieved on time, why timer is expired, so all those things. But with this training, if you ask for a question, why BGP is not healthy, it will give you the let's say like PPI packet is not received from the BFT. The other end link is down. So those information clearly extract and I'll show it to you. That is one use case. The second, especially, is most useful for the developers, where if there is a issue in the testing, all we get is the tech support. So if you feed the tech support, you can simply run a query, say, show me the root cause. So if there is any process crash or any failure events, it will tell you why that happened. There are other aspects you can use this intelligence, like monitoring the security of the system, like any intruder logged in, how many times user entered an incorrect password. There are so many things you can analyze, but I would say like these are the main two use cases, like healthy of the system is one of the main use case, and second, it will help the developer analyzing the tech support. So, how the AI does this analysis? So, traditionally what we will do, we get lot of log data. Mostly we will, if there is an issue, we will restrict this particular time and then we will take the log and we analyze the possibility of issue. So, for example, one issue we could struggle a lot, like there is a ECC error in the RAM, but that log is wiped out because of log rotation. And because of that, there are malfunctioning in the process, and we could not figure out why that process crashed. But if AI was there in that case, it will immediately detect that error and it will take up preventive actions. If it is error, it will immediately report and it will alert the user. It's a traditional log is a reactive analysis. We all do like we analyze the log once after we get into once we get the problem. Definitely a manual human intervention is required because we are not expert in all the areas. So, BGP, if it is a problem in BGP or any other system issues, respective people will have to dive into and then they have to see the issue. But with AI, it knows everything, whether it is a protocol, whether it is a system, whether it is a hardware, it understands everything. So AI, the advantage of AI is like it is autonomous. So, once you start the monitoring tool, it will run in the background, it will automatically watch for each log, and if there is anomaly, it automatically detect and then it will backtrack the logs and it will do the root cause analysis. And it is a context based. So, what it means, if you are running in a system, you would see the log will not be a continuous. You will see one log from SNMP, one log from BGP, one log from Fabric. Multiple logs will be coming in random order. So, the AI what it will do? It will classify the logs and build a context on it. So, if you want to see something on the particular container, the analyzer will look only to that particular container. If you want to, if it's a generic problem, then it will look for all the context. It's a context based and it can work with offline mode as well. So, once we have a schema model and we can copy that model anywhere, we can take to offline and feed the logs, you will get the result. There are two things here, supervised learning and unsupervised learning. Supervised learning means we need to feed all the logs for the training. I mean, we need to tell, for example, I took the use case of system is running in low memory. So, that is the log as an example. We need to feed this training, neural network such that this is anomaly log, and we need to basically boost its attention. The priority of that log message, it has to be, we need to be boosted higher. So, during that training, we need to give the weightage for that log to be higher. But with support of LLM, that weightage will be automatically calculated. So, there is no need of human interventions required. So, this is how it is different from the regular your neural network and the LLM based AI. So, regular neural network works like a classification. So, for example, you have a cat, cow and tiger, you feed into the network, you need to tell, it will give the output, you need to tell I gave the input as cow, you need to classify it as cow. If you feed tiger as an input, you need to tell I want output as tiger. So, that classification we have to set ourselves during the training. But with LLM, it automatically classifies. You can input the 100 cows, you can input 100 tiger images, and various animals you can give an input. The LLM automatically classifies category 1, category 2, category 3. So it automatically detects this particular input is belong to this category. So in the that is the difference between supervised and unsupervised learning. So with our POC we used both, because if we know this particular thing is we want to be treated as higher weightage, we can tell during training itself. If we don't know, then we can use unsupervised learning on top of the supervised learning data. That way it will be, that data model become super rich. So unsupervised learning we generally deployed even in the customer environment where I'll talk about the deployment scenario, but if the unsupervised learning we can use it at the runtime. So let's see how AI actually works. If you take, for example, so AI is nothing but it's statistical math, as I said before. Everything will operate on numbers ranging from 0 to 1. So if you feed any input, we need to convert that input into a number. So that's the primitive part of any neural network. So once you have the number, let's say for example, I will give an example. Say I want to travel from Hyderabad to Bangalore. That is my input. I trained the model such a way that from Hyderabad to Bangalore by car it takes 7 hours. That is the training I feed into the model. So during the training, what we will do in the beginning of the box, so we do a lot of layer calculations, and each layer will do some weightage and computation calculation, and finally we will take it to one value that is ranging from 0 to 1. Let us say the value is 0.78. So we label that as travel. You consider that as an example. You value that value 0.78 as a travel, and now you feed the input like I want to travel from, or I want to go to Bangalore from Hyderabad. That is the input you are feeding. So what this network will do, this also will convert this sentence into numbers and then layers of calculation. At the end, it will try to come to the value close to say 0.77 or 0.79. That is the value it will reach. So the network, what it will do, it is a statistical math. So our value is somewhere in the 0.7 dot something, and the neural network has learned as 7.8, which is the closest match. It will pick that value. So what neural network will do? So this 7 is closest to 7.8. So it will pick that word. So what is that? Travel. So what that context we built for? If you go from Hyderabad to Bangalore, it will take 7 hours. That is the sentence we trained. So if you give this input, the neural network will automatically give this output. If you go by car, it will take 7 hours. That's how the mapping happens in the neural network. This is the logic behind the all neural network black box. So we use lot of layer calculation in between to bring that value closer to each other. That is the simplest understanding you can compare it with. So in the log processing, what we will do, let's say take an example. System is running in a low memory condition where it generates the log as system is running low memory, and what this tokenizer will do, it splits each each word, and then it will assign the numeric value. So, here one key catch is here, like if you so basically the value is nothing but you build a dictionary with a list of words that is only required for SONiC. If you build a dictionary, what ChatGPT does, he build a dictionary with a complete list of words used in the internet. That requires a huge dictionary. So, we do not have that much space to run on our device. So, what we will do, we will take words which are essential to analyze the log, only that keywords, that words we will put it into the dictionary, and we will take that position as the numeric value. So, system is sitting on the 200th position, east is 301 position, running is in some that index of that word in the dictionary. Next thing what we will do, we generate it is a single value, all AI neural net will operate on a vector or on the matrix space. So, we need to convert the single value into a array of vector. So, that is what the embedding is. So, we scramble that value so that it is unique in the vector space. So, we will generate the each vector for each word. Next thing what we will do, the positional encoding. So, this is more important. Let us say we have two sentences, system is running in low memory, the second sentence is system is not running in low memory. So, both the sentence you can find most of the word except not, but we need to differentiate the memory in two of the sentences. So, for that what is the positional encoding? What it does, the word is occurring at which place in the sentence, that is called positional encoding. So, in the second sentence it might occur in the 7th place, in the first sentence it might occur in the 6th place. That will differentiate the importance of that word in a sentence. The another calculation we add to the layer, the self attention. So, if you take this example, system is running in low memory, we compare each word with each other word. So, here you take the word as low. So, how much importance to the other word? So, we need to calculate the weightage for that. So, here low is more weightage to the who is the subject, the system. So, system is getting more weightage, and low is who is it is indicating to the memory, the object. So, the memory is the highest weightage. So, the connection between low to system and low to memory, these two space will get higher weightage, other words will get the lower weightage. So, that so we will semantically making this as this sentence into some meaning. So, here system, low, memory, these are the three things which is semantic of the entire sentence. If you map that word into a two-dimensional space, this is like how closer each word. If you look at the upper vector space, the system, low, memory, it is all closer, and the running is a little far, but I think actually if you take in the real representation, it will be far away from these two words. So, these are the input side processing we will do. So, to bring the unique value for each sentence in the neural network output. So, the neural network is nothing but we just record each layer, how much weightage we have to give the importance for each input. That's the only thing it will do. You can assume like generally when we talk about neural network, they say we will mimic the human neuron such that the connection between each neuron will represent it as a weight here in the neural network. It's almost the same concept here. The connection between, so you can see in the diagram. Yeah, so we have 4 input node and each node is connected to all other node. You can easily understand, let's take an example where a dot is a triangular of 10 by 10 pixel where everything is black. You have one dot in the somewhere in the bottom left. Okay, so the value of the dot is, you can treat it as value 1 in the neural network space, because off means 0 and 1 means you can take it as 1. But in order to neural network to understand, we need to say from the first neuron this is how far this, second neuron how far this. So this neuron is depends on all other neurons. That's the derivation we need to make here. So only then we can say like this dot is actually a lower left corner. If it is there, then this is the input match. That is the key idea behind this mapping. So basically we take each neuron and compute with all other neuron calculation. In this case, the neuron which is there in the dot, that will get the higher weightage, rest all neurons will get the lower weightage. So that information will feed into the next layer, and next layer if something else we need to take, how much dark it is, or positions, all there are different metrics we can feed input, and then finally we will get a numerical value. That is the learning what we do in the network. So the output what we will get as numerical values. So what we need to do, we need to convert that value into a meaningful sentence. So that's what the output decoder will does. Let's say we take 72. So that actually it means that check the system usage, and if you say 43, you can say check the buffer status. So that is the learning we learned in the network. So if you say system is running in low memory, and these are the things we need to do in the output. So in the learning we can do multiple combination, like you can report to the user that you can check all these things, or you can say take the action by neural network itself. Like when you detect that input log, you run all these commands and give it to the user. Third alternative what you can do, run get the output. The output is again fed into the another network that will tell what action need to be taken. If really system is huge memory, say one of the parameters says system buffer, there are huge packets laying in the kernel, because of which the buffer memories are high, and that is why the entire system memory has gone down. Then buffer status will show that output, and from that output you can define the action, like you release the buffer by running that page cache, drop cache command. So all these things we need to feed and train the neural network, then it will do whatever the action we trained, it will do accordingly. So the training model what we tried, one input, yeah, obviously the SONiC log files. There are other the actionable sequence what we described here, what we need to do. So right now what we did, we just dump what action need to be taken, but this can be enhanced into, like you can run the command and take the output, feed into the another network and take the action. If something needs to be, like for example LACP process is taking huge memory, and you see something wrong with the processor, there is a memory leak, you just restart that process. Action, you can say just restart the process. So the action, we can define what action need to be taken, and there is another layer of action where it's a chain of thoughts. That is the core fundamental part of OpenAI. This is the one which it will understand the semantic of the sentence. So it will split the sentence into a smaller part, and it will give the meaning to each of the sentence. So this is the input. Majority we will feed this input to the training model. For example, if low memory, whatever we showed this data, right? These are the training label input for the neural network model. But we cannot predict all the combinational label data for the neural networks. Whatever we know, we can feed. There are unknown scenarios will be there. For that, we need to feed the data wherever it is possible. So we used SONiC, all the SONiC draft documents. So it understands each feature, what it does, and PF RFC drafts, even design documents, even the source code we fed, like where the log message is coming from the source code and at what condition it is coming. So there is a separate model. We just it's readily there. We just added here, and we just added the training with the existing model. So basically, what it does, log message, where it is coming, at what condition it is coming, and on what is the flow in the source code. This can be, there are a lot of opportunities in this, but I'm scared actually. Even you can tune this logic. You can give a fix for that also. Like if the log is coming, if it is error, that itself will provide a fix. Somebody says like all the network jobs will gone in 20 years, but if this comes, our jobs is also gone. Yeah, functional flow. I mean, whatever that is helpful, we can do. It's up to us how much we can restrict here. Yeah. So this is offline, I mean log interpretation, where you can run the queries on the model. Just so log Ethernet 22 port flop status. It tell you what time first, I mean what all the flop logs, what time it happened, all the information it will give you. What the last time the BGP got restarted. It's everything from the log. In the offline mode, this is the one useful feature I find because I am a core developer. So from the tech support, just run last crash root cause analysis. It will give you why that crash has happened. Yeah, any hardware critical events, it will like ECC, port timer error, any other hardware events. It's all this log is mainly like some of the logs are generated by the Linux, so that it will track that as well. So that is quite useful to detect. Like kernel, there are a lot of events. Majority of the events handled in the kernel. It will be especially the packet, buffer, netlink messages. Sometimes the netlink packets are dropped in the kernel. We never know why the netlink message is not reaching the user space. So those sort of things, it will be easily, you can easily catch it here. Yeah, so in the deployment aspect, you can run this the detection process in the device itself, but it will take a little bit of CPU. But it will work. It will run on at node level, so you can isolate whichever node you can isolate easily. That reinforcement learning is the problem here, because we cannot run any new logs. If you want to relearn then we need to feed the log into some external server, and that need to relearn and then apply that schema back to the node, because the computation of learning is huge. Network level, you can have centralized server where you can just configure your server to forward all the logs to the centralized storage, where we can run high powered CPU, GPU, we can run this analyzer, and along with we can run reinforcement learning, where it will analyze the log as well as it learn by itself. But in the external mode, yeah, probably we need some high powered resource. So we used some of the Python tools. If you are running in a device, we need at least 128 memory. On an 8-core system, the analysis takes 5 to 10%, but still it can be tuned. Like we can analyze only the error logs, critical. We can restrict what log to be analyzed. So if you reduce to error log, then it will be like 1 or 2%. But if you analyze all the debug logs, it will take some percentage of CPU. But yeah, there are a lot of opportunity to fine tune this. Yeah, it's just a beginning. We need to develop more on. I mean, this is one example for where we can utilize the AI into SONiC, but a lot of opportunities. There are flows we create in SONiC, right? You can use AI to classify the flows and which is coming more. Any drops, which flow is getting more drops or more unfrequent. A lot of analysis can be done. I think somebody presented the fabric stats. We can use AI. There are other aspects like, especially in the configuration space, a network administrator, where they need to do a lot of configuration things, right? So I mean, even I find difficult, like we want to configure some VLAN or some protocol, and to log into SONiC CLI and go into the config mode and then enable configure IP. Though a lot of things we need to do. With AI, just configure VLAN 10 on port Ethernet 22, it generates the command and run. So that is another possibility we can add on. There are numerous opportunities to empower the SONiC with AI. Any questions? Yeah.
I'll pass the mic.
Hi.
Hi, nice presentation. I have a question, like if you have a remote syslog server and it is receiving logs from multiple systems, so in that remote server, can it analyze which system has a problem?
It is a context based.
Yeah.
Even in the per node level, it is a context based, per container level, per process level, per protocol level, it builds the knowledge. So even the centralized, from which node it is coming, it will create a context under which it will create subcontext.
So if there are 10 systems
sending a log,
logs, it can identify which system has an issue and can generate any report
events.
I guess intruder events also user will be alerted, right?
Yeah.
Okay.
It's it depends how much how many logs we are sending to analyze. Like if you send all the debug logs, definitely. Like if you configured like maybe 10-20 servers in a single centralized location, and only one model will be running, then it will be a bottleneck. But not to speed up more, at least we need to deploy 2-3 processing units along with the centralized unit.
Okay. I saw a slide in which you spoke about it works with uncompressed logs only, right?
So it depends. Like generally, when we do show log, it is only uncompressed. But the model builds the knowledge for whatever the logs come so far.
Okay. Thank you.
Hi. Here, this side. So I just wanted to ask you, what large language model did you try and tested this analysis on? Was it like
Llama 2.
Llama. Did you test it on Turbo GPT? Was it tested on Turbo GPT 4?
Yeah.
So you did? Okay.
Yeah.
Did you find any difference in other large language model?
No, we took whatever the open source one. So Llama and there is a BERT.
Okay.
Only these two we tried.
The other question is that there could be like companies who are very much predominant about the data security, right? So when you upload these logs to LLM, right? How do you guardrail that and make sure that these data are not being passed across? Is there anything that you specifically do with that guardrail?
Yeah. So still, even if you configure device to forward the logs to central server,
right,
central remote server, still the analysis will be restricted within that domain.
Within that domain.
Right? Yeah,
so
we are not sending outside.
That is not outside.
It's all private model.
And did you also thought about the hallucination part of it, like to use any
actually
RAG or
sometimes we observed like incorrect this. It's about tuning. Lot of even you might have seen like lot of papers is coming every 2 months.
Right.
There are a lot of tunings happening in the COT and LLM. Yeah, we need to also follow their path and to optimize the try to avoid the hallucination.
So where do you see this product like maybe another year down the lane? How perfect that could be?
Definitely after POC we have a lot of confidence. Definitely we can bring into a deployment.
Thank you.
Yeah. At least not in full stretch level. At least we take the core error log level, error and critical log,
right,
that feed into a model, and it can at least alert and take a preventive action.
Thank you.
Yeah.
I think overall good presentation. Yeah. I have one question. This concept is there for quite some time.
Yes.
And now we have Elastic, we have Splunk, for example, who can do all these things out of the box. So what I'm trying to understand is the motivation behind why we want to add it in SONiC. Means anyone can just go and buy a third-party application which can do everything, whatever you mentioned, out of the box.
No, so nobody is telling what is the matrix calculation, what is the weightage adjustment, the COT, like chain of thoughts. There are a lot of rethinking and relearning approach. There are whatever the open source papers, only that is there, but it's still ChatGPT, it's not fully revealed. Even Copilot is still influencing ChatGPT, right? So even Google's Gemini is so private. So
are you planning?
We can one business opportunity, I would say, we can train the model and then we can just upload it so that everybody can use it.
So you are basically creating a sample model and
on top they can train their own.
And they can train the.
Yeah.
So the presentation was nice. So here.
Where?
Yeah.
Oh, okay.
So Llama generally would require close to tens of GB of memory, right? How did you bring it down to 128 MB?
No, this is only to the analysis part.
Okay.
The training will take a lot of CPU, a lot of high power CPU required.
So
what I did, there is a Llama free model is available. Right. I take that. On top I trained whatever required for SONiC. That's a POC, but if you are starting from full completely open source, then we have to train ourselves and generate the model.
Okay, while training, what kind of data, what is the breadth of logs, what all to train with?
So whatever we during our internal testing, we get lot of logs that whatever I showed, right, the input, it's gone, right. Logs and the open source documents, drafts, design documents, and even source code. Whatever is available, I just feed everything into that.
So how much memory did it finally come to?
This model memory, right?
Yes.
It is like 800 GB or something.
Okay.
But in compressed, you can bring it down. But still, we fed lot of unwanted dictionary words are there. So if you strip out, it will become like 200, 100 MB.
Okay.
Yeah.
That's nice.
Just one last question. This is Anand from Marble. Quite a detailed presentation. These, whenever you work with LLMs, there is a chance of hallucination, right? So what was your experience working with?
Even we faced a lot of hallucinations.
So what was the accuracy and how did you overcome?
It again depends how much training we feed. Even in ChatGPT, first time it came, I surprised, like I asked who is mother of Tom Cruise. It says Mary Jessie. And who is son of Mary Jessie? It didn't answer. So it's all we need to feed. He is the son of, I mean, bidirectionally we need to feed the input.
Okay, sure.
Now they optimized and now it will do a lot of intelligence, but the earlier version, there are a lot of inconsistency.
Hi. Hello. Is it readily available in the community now?
Right now we are at POC level.
Okay.
To production, it will take maybe 6 months to 1 year.
Okay. Because I was very fascinated listening on to your presentation. Because as a developer, moving from some other protocol stack to SONiC, as a developer, we are facing a lot of pain in terms of debugging, especially.
Yes, yeah,
we have to scroll through the syslog.
That is one of the motivation to
yes.
get into this.
Actually, it's a big sigh of relief.
Yeah.
Thank you. I'm looking forward.
Sure. Okay, thank you.
Cool. Thanks a lot. Great presentation. We'll take like a 10-minute short break and then we will start. We have 2 more sessions left and then we have a few more things have been planned for the evening. So let's take a 10-minute short break and then we'll start.